Hello, everyone. Hopefully you are doing well. We are just going to continue in chapter 10 with homomorphisms. Now, we talked about the first isomorphism theorem, and I just want to add a corollary from that theorem. So we proved that theorem in class, and what that tells us is basically we can take a factor group and make it's isomorphic to a simpler group. And the power in isomorphisms, and I know because of class time and everything, to really emphasize the fact that isomorphism, when you say that one group is isomorphic to another group, then whatever. So the importance is that when you have a group and you say it's isomorphic to another group, then whatever properties or structure holds for that group, it also will hold for the other group. Now, unless you to see that clear mapping, like when we did that example in class and we saw that from that factor group to phi of x, when we were talking about 4z, we saw a clear mapping, right, from the cosets to a number, okay, one of the numbers in Z mod 4. So we know a lot of properties about the cyclic subgroup Z4, Z mod 4, right? It's the cyclic group, it has generators, we know the orders, we know how many, we can find the orders of each of the elements. And so what that tells me is whatever properties hold. So that is really, really powerful, especially when, and one of my favorite quotes in mathematics is not about making simple things complicated. It's about making complicated things simple. And showing that two groups are isomorphic, that's the essence of trying to make something that could look complicated a lot simpler. And that's expanded in terms of applications. Although this is a pure math class, in terms of applications, we could think about, okay, in differential equations or other courses where you model something, you're trying to mimic what actually could happen in the real world and make predictions based upon that. And so if we know, and there are applications now, and more people realize that pure math can, in some aspects, be applied to the real world. And that's where sort of graph theory came about, sort of like thinking about number theory applied to code breaking and things of that nature. So I'm just getting off on a tangent, but I really want to make sure you understand, if we're saying that two things are isomorphic to each other, then they're the same. That's in essence, they might look different, but they're the same, such as, speaking in one language and translating in another language. Okay. And so the corollary says, if phi, so this is a corollary to the first isomorphism theorem. If phi is a homomorphism from a finite group let's say G to G prime, then the order of phi of G divides the order of G and the order of G prime. Okay, and you could try to prove that, shouldn't be too hard. I also wanted to look at a couple examples from this chapter 10, and then I'm going to do another video sort of introducing chapter 11, which is our last chapter of the semester. Yes. Okay, so let's look at this example. We can call this 1. Let phi go from C star to C star. Okay, and so that's the complex numbers not including 0. And it's given by this function here, phi of x equals x to the 4th. Okay, well, I'm going to show it's clearly homomorphic. It's clearly homomorphic since phi of xy And again, we can let xy be two elements in C star, right? And so that equals xy to the fourth. And because of properties, we can rewrite that as x to the fourth, y to the fourth, right? And that's phi of x times phi of y. Okay, and this is under multiplication, all right? Well, so it's a homomorphism. So then we can talk about the kernel of phi, all right? So all things mapping, so we're thinking about, so in this example, the kernel of phi are going to be all x values such that x to the fourth, since we're talking about multiplication, the identity is 1. So we want all elements that will map to 1, okay? Well, take a minute and think about that. Remember, we're on the complex plane. And so because of that, then our answer, you should have received 1, -1, I, and negative I. My screen moved a bit. Let's see if I can get this back. Okay. Yes, there we go. All right. Okay. So this tells us, if we go back to theorem 10.2, I believe property 5, that phi is a 4-to-1 mapping from C star to C star, okay? 4 meaning there are 4 elements that map to 1 element in the codomain, okay? So that's what that is saying, okay? And so for example, let's say we want to find all elements that map to 3. Okay. So if we want all elements that map to 3, then we want to find one element. And once we find one element that maps, then we're going to use the fact that we know these 4 elements are in our kernel, and we're going to multiply that element by each of those. Okay. So, well, to keep it, again, we can just say, I don't know if this is another clearly, hopefully this is another clearly the 4th root of 3, right, is going to, if we look at that, that's really 3 to the 1/4 to the 4th, right? Well, that's just 3, okay? So we found one element that maps. So now we just take this element here and multiply it. To get all our elements, we're going to multiply it by every element that's in our kernel. So thus, the elements that map to 3 under this particular phi are, you can write them as a set. So the 4th root of 3, -4th root of 3, and then what? 4th root of 3 times I, and -4th root of 3 times I. Okay. And so if you check, then all 4 of those answers will give you, when you put them in this function, they will give you 3. So that's what it means to have a 1-to-1 mapping, right? That's what we're used to, 1-to-1 functions, but 1-to-1, 4-to-1, so and so. Okay, so on and so on. All right, so I want you to try this one. Phi is going from Z12 to Z12, given by phi of x equals 3x. So 2 questions, and I want you to bring these. We'll discuss this in class for Friday. I want you to show that, I write it on here. Show that phi is a homomorphism Then I want you to state the kernel of phi. C, find all elements that map to 9. Okay, so I want you to answer this question. Feel free to use the book to help you answer the question and, look up. I'm only sort of pinpointing and highlighting things. I'm leaving it up to you all. If anything isn't clear in my notes, to go back and read, and hopefully you're able to fill in the gaps, or you can, of course, ask me questions in class. All right, so we're done with this video. I am going to make another video introducing chapter 11, which will be our final chapter for the semester.